So, in earlier video we discussed about the transistor and the types of the transistor. Now, we are going to discuss about the working of a transistor, either PNP or NPN. Means here first of all we are going to see that what is the PNP transistor, working of a PNP transistor. Already we know that. From that, here in PNP transistor circuit consists of emitter, base, collector. In this case, the holes are the majority charge carriers, which can in the transistor the holes are the majority charge carriers in the resistor, in the transistor. So here it is that this is emitter, base, collector. Consider this PNP transistor circuit is biased, the common biased by the collector, and emitter is commonly biased at the base, and both are commonly biased, and that there are two loops are there, and this one is the one loop and this one is the another loop. Means here emitter base loop here once again, and base collector base is there, base loop is there. So from this, here that emitter base is given a small forward bias. Means here we know that this is PNP. This emitter is a P type of a material, and here N is a N negative terminal, means N type of a material. So that's whenever the P type of a material is connected to the positive terminal of the battery, and N type of a material is connected to the negative terminal of a battery, it is a forwardly biased. The small forward bias given to this emitter base junction, emitter base region, given a small forward bias that can be emitter can emit the electrons, holes from the P type of material, and base can transfer that into the collector. So here it is that a small forward bias connected in the emitter base region, and if we come for the second loop, that is the base collector region. In the base collector region is given the high reverse bias. High reverse bias means the negative terminal of N type of a material connected to the positive terminal of a battery, and negative terminal given to the P type of a material. Means it is reversely biased. Whenever it is reversely biased, then the circuit is sum of the circuit, means emitter base junction given a forwardly biased, a small forward biased, and base collector junction given the heavy large reverse bias. In this case of when forward bias, in this forward bias we know the conduction will be possible. When forward bias, the emitter base region, in the emitter base region, holes moves from the emitter to the base. Holes moves from the emitter to the base. Most of the holes, up to 98% of the holes moves from the emitter to base, and remaining percent, means 2% of the holes will combine with the electrons, which is at N type of a material. Means whenever they combine, due to that combining these 2% of less amount of holes are combined with the electrons in the base, so that base current flows through the circuit. Means here the base current will be possible due to that whenever the emitter base region is forwardly biased, most of the holes will move from the base and enter into collector region. Means whenever this is forwardly biased, once again, whenever the emitter base junction is forwardly biased, this emitter will emit the holes and enter into the base. Most of the 98% of the holes will move into the collector region, and remaining 2%, up to nearby 2 to 10% of this 2% remaining small amount of percentage of holes will combine with the electrons, which is at in N type of a material. So that here is that due to that recombination of the whole electron, the current will be possible, that is base current is flows in the circuit, that is called a small current, that is base current, that is called IB, that is IB, and the holes enter into the collector region and combine with the electrons, which is provided by the battery negative terminal. Means the 98% of the holes is emitted from the total holes are emitted from the emitter and reach to the base, and that base is 98% of the holes are transferred to the collector. In this transferred holes are combined with the electrons which is provided by the, because of it is connected to the negative terminal, the holes are positive and the terminal gives the negative electrons. So that's why here the amount of 98% of the total amount of current will comes from the negative terminal. Whenever it gives the electrons, then the holes are combined at the, due to the connection of the reverse bias. This is attracted by this. This is holes are combined with the electrons at the collector region. The holes enter into the collector region and combine with the electrons coming from the negative terminal, that is the collector current flows, that is IC means collector current. This causes collector current. Both this collector current as base current constitutes the total emitter current, because of in external circuit the majority charge carriers, in the transistor the holes are the charge carriers and in external circuits the electrons are the charge carriers. So that's why here, due to that, here both collector current and base current constitutes together the emitter current will be happen. That is IE is equal to IB plus IC. So base current nearly in the emitter current, base current is nearly to up to 2 to 10% and collector current is 90 to 98% will be constituting the total emitter current. Means in the emitter current, the less amount of current will be base current and most of the large amount of current will be collector current. Once again, the working of a PNP transistor is by connecting this PNP transistor to the batteries in such a way with the common base bias, then here the emitter base, E means emitter, B means base, C means collector. So emitter base junction connected, emitter base junction means our emitter base region is connected with a small forward bias and base collector region is connected for a large reverse bias. When we connected the forward bias, due to this forward bias the emitter emits the holes, large number of holes into the base. And a base, from the base holes 98 large and most of the holes will transfer to the collector by the base and remaining small amount of holes will combine with the electrons in the base. So that that causes the base current, and whenever the holes are reached to the collector and combine with the electrons which is coming from the negative terminal of the battery VC. Here once again, whenever in the base current, in the base current the holes are entered, some of the holes will combine with the electrons, then the electrons will leave the negative terminal, because of here the negative terminal is there now. So that's why here in this case of electrons, whenever they combine with the holes, they leave the negative terminal and combine with the electrons, and due to that this causes the base current. And whenever the maximum amount of holes are entered into the collector, then they combine with the electrons which is coming from the negative terminal of the battery VC. So that causes the collector current IC. So in that case the collector current and base current both together constitute the emitter current. So in that emitter current, the base current is 2 to 10%, means less amount of base current will be constituting the emitter current. And most of the current will be collector current, that is up to 90 to 98% for the emitter current. This is about working of a PNP transistor. We are discussing about working of a PNP transistor. Now we are going to know about Npn transistor, the second type of a transistor, which is Npn transistor. Already we discussed about it. Npn means the P type of a crystal is sandwiched with the another N type of crystals, two crystals, then that is called as Npn transistor will be formed. And in case of NPN transistor, this is a N type of a material and P type of a material is sandwiched, and this is also another N type of a material. And this first one is lightly doped, and here whereas emitter is a heavily doped material and base is a moderate lightly doped, and this one is a moderately doped. So that's why here it is having the more, these two are having the electrons are the majority charge carriers in the circuit in these crystals. And as well as NPN transistor connected in the same bias as earlier we discussed about the PNP transistor, same as here also. The emitter base junction is forwardly biased. Means here NPN transistor is there. In case of this one is N and this one is P type of a crystal. So here it is that the negative terminal of a battery VE is connected to the negative terminal of the N type of a crystal at the emitter, and at the base the positive terminal of the battery is connected to the P crystal, it means base. So this is a lightly forward bias, that is with the VE. This is the VE is the battery. VE is the battery, with the battery small forward bias is connected. And the base collector junction is connected reverse bias. This is P type of a crystal, so that's why the base, this is the negative terminal, this second loop, this one. And this is the N type of a material, means N crystal, so that's why here this is connected to the positive terminal, means reversely connected, so that's why it is a large reverse bias. Largely reverse bias. The operation is also same as PNP transistor. Here emitter emits the electrons which sent to the base. Emitter emits the electrons due to the forward bias. This one is a negative, and this is also N type of emitter. So due to the repulsion, the total electrons move towards the base emitter junction and jump from the junction and enter into the base. And when the base is sent, the base as well as this one, the most of them sent to the collector. The remaining electrons are combined with the holes, which is provided by the positive terminal of the battery V, which is connected V. So that here whenever these are holes, electrons are combined with the holes in the base, then the bond breaks. The bond breaks in base region and produces whole electron pairs. Whole electron pair. This constitutes that is IB. IB means base current. Once emitter emitted the electrons and enter into the base, when 98% up to most of the electrons are sent to the collector, the remaining percentage of collectors are combined with the holes. Whenever they combine with the holes, the bond breaks in the base region. That constitutes that base current. Is in the direction, means emitter current is follows like this, and base current is in this. So that's why the current will flows in the circuit. Base current, the small amount of base current will be flows in the circuit. The electron captured by the positive terminal. So that here the electron, whenever electron captured by the positive terminal of the battery, that VE, and sent towards the emitter region. Sent towards the emitter region. So that this causes the sum of the base current. Once again, when emitter in forward bias, emitter base junction, the electrons move towards the base. Most of them sent to the collector. Very few of them are combined with the holes, and whenever they combine, the bond breaks at the base region, and the electrons are acquired by the battery, positive terminal of the battery, and sent towards the emitter, region. This causes small base current in the circuit. So when the remaining most of the electrons are entering into the collector, this collector alternatively positive terminal of VC acquired by this entered into the positive terminal of the battery, it will be attracted by these are the negative charged particles, and this one is the positive terminal. So that's why the entered electrons will attracted by the positive terminal of the battery Vc, positive terminal of the battery Vc, so that the collector current constitute. This causes the collector current Ic. This causes the collector current Ic. So that this base current and collector current together constitutes the emitter current, same as earlier we discussed in the Pnp transistor also. So that the collector current and base current both constitutes together the emitter current. The base current is less 2 to 10%, which depends on the doping level. Depends on the doping level. And also here collector current will be up to 90 to 98%. This is collector current, and a base current will be 2 to 10%. So that here the emitter current will be collector base current plus a collector current. This will be the total emitter current, together the collector current and base current. Once again, in that NPN transistor, the emitter base junction, emitter base junction is connected in a small forward bias with battery V, and base collector junction is a large reversely biased battery Vc. Due to the forward bias, the electrons are emitted by the emitter and sent to the base. In that emitted electrons, most of the electrons are sent to the collector, and some of the electrons will combine with the holes. Whenever they combine with the holes, the bond breaks at the region and forms hole electron pair. So that due to that pair, the positive terminal attracts the electron and sent towards the emitter region. The positive electrons are attracted by the, some of the electrons which are stayed in base will attracted by the positive terminal of the battery VE and sent to the emitter region, so that causes base current, small base current in the emitter base region circuit. So when the most of the electrons are sent to the collector, the electrons are attracted by the positive terminal of the battery Vc. So that causes the collector current in the circuit. So that IC, collector current and base current together constitutes the emitter current. So that emitter current nearby the base current is nearly 2 to 10% of the emitter current, depending upon the doping level, and the collector current remains 90 to 98%. Here the electrons are the majority charge carriers. The electrons are the charge carriers in the transistor as well as in the external circuit also. Because of the electrons only in external circuits, so in always due to the electrons only the current will be passes through the circuit in external circuit. So that's why in the PNP transistor or NPN transistor, in external circuits the charge carriers are always electrons, but the holes are charge carriers in the transistor when in the PNP transistor, because of in PNP transistor holes are the majority charge carriers. So that's why in the transistor, with the transistor only the charge carriers in the transistor is holes in PNP transistor. In NPN transistor, electrons are majority charge carriers, and in the external circuits of PNP and NPN transistor, both the electrons are charge carriers. This is about working of PNP and NPN transistor.